So in this video, I'm going to talk about the product rule. And again, we start with what we actually want. We know that if you have one function multiplied by another function and both are differentiable, then the derivative is f prime of x times g of x plus f of x times g prime of x. So how do we get there? Start with our difference quotient. The limit as h approaches 0 of f of x plus h times g of x plus h minus f of x times g of x all over h. And the nice thing about this is wishful thinking here. I know that my answer has to have four pieces in it because of my f prime g plus fg prime. And right now, I only have two pieces in the numerator. So wishful thinking says, let's just make it work. Let's add in f of x plus h times g of x. And if we add something out of the blue, then we should subtract the same thing. Now, why would I add and subtract that same thing? Well, it gets me to four pieces, and each of my pieces has something in common. So now I can group things that have the same factors in common. So what I'm going to do is I'll group this piece with this piece. So I have one positive and one negative piece because then that gives me a difference quotient to work with. And I'm going to group this last piece with this first piece. So we're going to rewrite what we've got down here with our new groupings. The limit as h approaches 0. So we have the purple pieces, f of x plus h times g of x plus h, minus the other purple piece, f of x plus h times g of x. And then we have the green piece. I'll do the positive part first, f of x plus h times g of x, minus the other green piece, f of x times g of x. Oops, almost ran out of space. All over h. So next thing we'll do is factor some stuff out. On my first chunk, they have an f of x plus h in common. So I'll factor that out. And you can also distribute the limit to what is remaining. The reason I'm allowed to distribute the limit is because the original functions of f and g are also differentiable, and differentiable implies continuous. And when things are continuous, then you know that the limit exists. So I've distributed the limit on the first chunk of stuff. I'm going to do the same thing for the second chunk, which has g of x in common. So limit as h approaches 0 of g of x. And then the limit as h approaches 0. Move my little face out of the way. Limit as h approaches 0. So after I factor out g of x, I have f of x plus h minus f of x all over h. And because they are continuous, all the derivatives exist and approach the functions. All the limits exist, excuse me. And so the first one, as h approaches 0, this becomes f of x, regular f of x. This is the difference quotient for g of x, so it's g prime of x. And then over here, this piece is just regular g of x, because it doesn't depend on h, and this is f prime of x. And that was what I was supposed to prove. I guess I wrote it backwards, but with addition and multiplication. It's commutative anyway. So there you have it. That's the proof of the power rule from first principles.